Hey, this is a video on linear relations. Okay, so we're talking about linear relations, and we're going to do that by looking at patterns. Okay, so I've got these little square tiles, and I've created a pattern. So my pattern starts with 2 tiles, and then it goes to 4 tiles, and then 6 tiles. And I'm calling these terms. So this is like term 1 and term 2 and term 3. So like based on my pattern here, how many tiles would you predict there would be in term 4? If you had to predict the number of tiles, there would be 8, because we can see that this pattern is actually increasing by 2 tiles every single time. So that would be 8 tiles in term 4. And what if I even backed it up to like something called term 0? How many tiles would we have? We would have no tiles, because since it's going up by 2 every time, it would make sense to have 0 tiles, and then 2, 4, 6, 8. So I'm going to use this pattern to teach you how to make a table of values, a graph, and then some important features of linear relations. So linear relations describe things like a pattern that increases by the same amount each time, or decreases. So this pattern is going up by 2 every time, so we would call it a linear pattern, and it's growing by 2 every time. So I'm going to make a table of values with this pattern. So I'm going to, in the first column, I'm going to put the term number. That's going to be called my independent variable. That's just the variable that it's just constant, like it's 0, and then it's 1, and then it's 2, 3, like it's just going to go up regardless. Whereas the number of tiles, that's going to be my other variable, and it's going to be called my dependent variable. Because it depends on the term number. Okay, so if I started at term 0, there are no tiles. Term 1, I have 2 tiles. Term 2, I have 4 tiles. And in term 3, I have 6 tiles. So I can see that my pattern is increasing by 2 every single time. And that's really important, because these things right here, we refer to as, sometimes we call them the first differences. So they help us determine if a pattern is linear or nonlinear. And in this case, our pattern is linear. So here's how we could take a pattern and put it into a table of values. And I was saying in the text above this video that you can actually create this thing called a pattern rule. So it's something that could help us predict the number of tiles. So like, for example, if I wanted to know how many tiles there would be in term 50, it would be really annoying to just like add 2 every single time, because it's going up by 2s. So I need a rule where I can figure out like term number maybe times something could get me the number of tiles. So I'm kind of looking for like an equation that I could go from the first column to the second column. So we're looking for like an operation that happened to the first column to make the second column. And I think that operation is multiplication by 2. So like, let's think about this. If I multiplied this by 2, it would equal 2. If I multiplied this number by 2, it would equal 4. If I multiplied this number by 2, it would equal 6. If I multiplied this number by 2, it would still equal 0. So it turns out this rule is term number times 2 will get me the number of tiles. So if I want to know how many tiles there are in term 50, I just multiply term 50 by 2. So I know there's going to be 100 tiles. So our pattern rule is kind of helpful. It's like the equation that describes the pattern. Okay, so I've made a table, I've got a rule, and I've made my that's it. What if I want to graph my pattern? So this first column, term number, that always goes on the x-axis, or on the horizontal axis. And then the second column, number of tiles, will go on my y-axis or vertical axis. Then I create a scale. I just went up by 1s on the bottom and 2s on the side. Then I just plot all my points. So I have a point at 0, 0. Then term 1, 2 tiles. Term 2, 4 tiles. Term 3, 6 tiles. So that's my pattern. And I know term 4 would have 8 tiles. Like I could keep this pattern going if I wanted to. There it is. And you can see it's linear because this produces a straight line. So I can see that right away that this is a linear pattern or a linear relation. All right, let's try a trickier pattern. Okay, so now I've got term 1, term 2, and term 3 for a different pattern. Here I've got four circles in my first term. Then I've got 1, 2, 3, 4, 5, 6, 7 circles. So it looks like it increased by 3 circles. Let's see if it did again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then it went from 7 to 10 circles. So it increased by 3 again. Now what if I wanted to get the next term? How many tiles or how many circles would there be in term 4? I think there would be 13 circles. Because if I just add 3. And what if I backed it up? What if I want to know how many circles in term 0? Well, if I subtracted 3, I would just be left with 1 circle. Okay, let's make a table of values. So I'll do term 0, 1, 2, 3, 4. So I start off with 1 circle, then I have 4, 7, 10, and 13. I can see that my table is going up by 3 every time, making this a linear relation. But now can I get the pattern rule or the equation? This one's trickier. So this time I can't just multiply this column by something, to get the second column. You know, like 1 times 2, that doesn't equal 4. 1 times 4 equals 4, but 2 times 4 doesn't equal 7. So here's a good idea. The amount that it goes up by every time is actually called your multiplier. So I can take my term number and multiply it by 3. So let's try this one. 1 times 3 is 3, and I need 1 more to get to 4. So I'm actually going to add 1 to my rule. Let's try it with 2. 2 times 3 is 6, plus 1 is 7. 3 times 3 is 9, plus 1 is 10. 4 times 3 is 12, plus 1 is 13. So my pattern rule works for every single term number. So now I could guess at term 50, 50 times 3 is 150, plus 1, there would be 151 circles. So that's my pattern rule. And something interesting is this times 3, we notice, is the amount that the pattern increases each time. And then this plus 1, I don't know if you noticed that, but that's actually the number of circles we have at term 0. So that's a really important number. Okay, and let's graph it. So we would put term number on the bottom, and then number of circles on the side. And then we would find something to go up by. So I'm just going to do up by 1s on the bottom. Oops. And on the side, so always start at 0. And then number of circles, maybe I'll go up by 2, 4, 6, 8, 10, 2, 4, 6. Yeah, that's good. 2, 4, 10, 12, 14, 16. So at 0, I have 1 circle. At term 1, I have 4 circles. At term 2, I have 7. At term 3, I have 10. And at term 4, I have 13. So you can see from my graph that, again, it is a linear relation. It's going up in a straight line. So that's how I could take a pattern and discover some stuff about it, like make a table, make a graph, and make an equation.